In this video, we're given an integral function, f of x equals ln of x to x cubed plus 3x of tangent of t dt. So an integral function is when one or both of our limits depend on our input variable, and we use this dummy variable t in our integrand. And we're going to find f prime of x. So this is going to be an application of our second fundamental theorem of calculus, in that we're looking for the derivative from ln of x to x cubed plus 3x of tangent of t dt. As you get practice with these, you'll be able to do them pretty quickly, because the second fundamental theorem makes them actually pretty easy. Because what we're doing are inverse processes. The integral involves the antiderivative, but then we're taking the derivative of it. So let's come down here to the next line, and we're going to take the derivative of. Now what we do want is to not have x on both of our limits. So first thing I'm going to do is I'm going to split this up into two integrals. That goes from ln of x to some constant a of tangent of t dt plus a to x cubed plus 3x tangent of t dt. This one's all ready for the second fundamental theorem. This one we need to do one more adjustment, and that's to make the ln of x the upper limit. But that's pretty easy to do from our properties of integrals. If we just make the integral negative, that switches the limits. And now we have our same integrand, tangent of t dt. And like we said, this one is already ready to go. And we'll have one more step, and we'll be all done. The next step is actually a very quick one, and that's to actually take the derivative. But as we mentioned before, these are inverse processes. So if you take the antiderivative of tangent and then the derivative of tangent, you get back to tangent. The other thing is our argument isn't x, it's actually ln of x. So this is going to be a chain rule. So from this first part, I'm going to do this, take the derivative of this. It's going to be negative tangent of ln of x, but we have to multiply by the derivative of ln of x because that derivative is a chain rule. So there's our first part. We don't have to worry about the a, because tangent of a would just be a constant. Derivative of a constant by itself is 0. Do the same thing on the second one. Tangent of x cubed plus 3x, and as we see, our argument is more than just x. So again, this is a chain rule, so we're going to multiply by 3x squared plus 3, and there's the derivative of this integral function.